In this video, we're going to have a look at the different ways we can describe distributions of data. When we're talking about distribution of data, we're referring to how the data is spread out across the range. Now, there are 4 different descriptions of the way we can describe how data is distributed that we're going to have a look at in this video. They are symmetrical, positively skewed, negatively skewed, and bimodal. So let's have a look at how these 4 look when they're plotted onto a histogram. If we have a look at the first one, we can see that the data peaks in the middle of the histogram and is evenly distributed on both sides. When the data looks like this, we call it a symmetrical distribution. Other names for it is either a normal distribution or a bell-shaped. This means our data is perfectly spread out between the upper and the lower range, peaking in the middle where the median and the mean will be located. Having a look at the next graph, we can see that it doesn't peak in the middle, but it peaks off to the left. On one side, we've got a fairly steep incline, and on the other side, a much more gentler incline of our data. When our data peaks early and to the left, we say that the distribution is positively skewed. It will normally indicate that there may be some outliers at the top end of our data set, and that we've got a lot of data at the beginning of our data set. When the data is positively skewed, our median and mean will likely be different. The mean will normally be higher because of the results of those outliers to the top end of our data set, artificially increasing the mean, where our median will be lower because that's where most of our responses occur. When analysing data that is positively skewed, you would use the median as a measure of centre, not the mean. Looking at the next graph, you can see that it peaks over to the right and not in the centre, with a steep incline down to the higher end of the scale and a gentler sloping incline down to the beginning of the scale. When our data distribution looks like this, we say that the data set is negatively skewed. When the data set is negatively skewed, it normally indicates that there's outliers at the beginning of our data set, thus throwing off our distribution. In a similar way, our mean and median will be different when our data set is negatively skewed. The mean will be smaller than the median because of the presence of those outliers or those lower numbers in our data set, bringing the mean down, whereas our median will be higher because a lot of our responses occur towards the upper scale of our data set. When our data set is negatively skewed, median is the better measure when measuring the centre of the data than mean. Having a look at the last graph, you will see that this one has not one peak, but 2 peaks. And then it dips in the middle between the 2 peaks. When our data set has the 2 peaks, we call it a bimodal distribution. And it's called bimodal because it has 2 peaks, or if we were to calculate the mode, it would most likely have 2 modes. Our data set may be bimodal if it has 2 different groups included in the same data set. If you get a distribution that looks like it is bimodal, then you can go back and have a look at the original responses, and you may be able to split it into 2 smaller groups to be able to analyse the data. So understanding and being able to describe the distribution of a data set is important when we are analysing the information contained within the data. So summing up how this impacts on our analysis, if it's symmetrical, if you want to measure the centre, you can use the mean. And if you want to measure the spread, you can use the standard deviation, or because we haven't learned how to calculate standard deviation, you can just use the range of the data set because it will give an indication of the spread. When the data is skewed, either positively or negatively, then if you want to measure the centre of the data set, you need to be using the median. And if you want to measure the spread, then you want to measure the interquartile range.